Today I'm here to talk about the ChiSquare test, which is inference for two-way tables. To do that, I'm going to give you one example problem and go through the entire process, giving you your notes along the way. And then I'm going to back everything up by showing you how you can do all this on the calculator. Let's get started. I have some people that are addicted to cocaine and they would like to get rid of their addiction. So I'm going to place them into a treatment program and they're going to take one of three drugs, dopamine, lithium, or actually a placebo. I randomly selected which group the subjects are going to use. 72 divided by 3 puts 24 subjects in each group. I then recorded if they did not relapse, meaning they did not go back to using cocaine. So out of the dopamine group, 14 did not relapse out of 24, gives me a proportion of success of 58.3%. Doing this for all three groups, you can clearly see a difference in these proportions, 58%, 25%, and 16%. I'm curious to know if there's a difference in these three proportions. In order to do that, I'm going to have to run a ChiSquare test. My overall test that I'm going to need is my ChiSquare test. And then I will give some analysis from that ChiSquare test, making a statement on whether I think that the three treatments are the same or that they are different. The first thing I'm going to do is make a two-way table of my relapses and non-relapses. So I already gave you that 14, 6, and 4 people did not relapse on their respective treatments. Subtracting those numbers from 24 gives me the amount of people that did relapse. Each of those entries is called a cell. There are 6 cells here. This is a 3x2 rows by column matrix. My explanatory variable is the treatment because that explains whether they did or did not relapse going back to using cocaine. The first thing I need to do is write down the null hypothesis. There's a few ways you can do this. One is with some shorthand notation. P1 equals P2 equals P3. We're saying that those three proportions, the 58%, the 25%, and the 16.7%, are the same for the three treatments. You could also write out a sentence here saying that there is no association between drug treatment and whether a person relapses. You could write a sentence saying that drug treatment is independent of relapse. Or you could also just simply say there is no difference among the three proportions of success for relapse. The alternative hypothesis is that there is a difference. The null hypothesis always that there's no difference among treatments. The alternative there is. I can write that not P1, P2, and P3 are equal, meaning that they are different. I could also write out a sentence. There is a difference among the three treatments, or there is an association. This is not a one or two-sided test, it's many-sided, because I'm comparing across multiple categories. In your ChiSquare test, I've given you the observed counts. You're going to need to find the expected counts. The expected counts as if we would expect the null hypothesis to be true. To do that, we're going to use a formula. Here's the formula for the expected count in all of my 6 cells in my 3x2 matrix, assuming the null hypothesis is true. You're going to take the row total, you're going to multiply that by the column total, and divide that by the table total. So first I need to find my row totals and my column totals. The row total for dopamine is simply 14 plus 10 is 24. The column total for my nose is 14 plus 6 plus 4 is 24. My table total is the summation of 24 plus 48, or 24 plus 24 plus 24, a grand total of 72 people that were addicted to cocaine. So here are my observed counts. To get my first expected count, I take my row total times my column total divided by table total. For example, the expected count for the yeses for discipramine, that's row 1 in column 2. In order to find that expected count, I take my row total, 24, multiply that by my table total, 48, and divide that by my entire total, 72. That has a value of 16. I need to go through this process 5 more times, giving all 6 of my expected counts. So after going through that, I have my 16 for yeses for discipramine previously found. Doing that 5 more times, I get 8 and 16 for all 3 no's and all 3 yeses. Now if you notice here, these 8 to 16's, no's and yeses, are the same because I expected no difference between my 3 groups, meaning the 3 proportions were the same. And that gives me that same proportion for all 72 subjects. My count of relapses, I had 48 people relapse. Out of 72 is a 2 to 3. Yeses to totals, which is my 16 to 24. 16 yeses out of 24 people, which is kind of what I would expect. Well, it does appear that discipramine does a little bit better job than the placebo. If you look, it has less relapses compared to the expected. I still actually have to run the ChiSquare test, though, to prove this. So let's continue running the ChiSquare test. I'm going to be comparing the sample proportions of success through the differences among the 3 treatments for the cocaine addiction. I'm essentially measuring how far are my observed counts from my expected counts in the two-way table. Here's the formula for the ChiSquare test. It's the sum of the observed counts minus the expected counts squared divided by the expected counts. I'm going to have to do this 6 times, 3 yeses and 3 no's for each of the drug treatments. So first, let's find the value for my discipramine non-relapses. I observed 14 people did not relapse, minus I expected 8. Square that value, divide it by an expected count of 8, gives me 4.5. Same process for lithium non-relapse, the placebo non-relapse, and then the relapses for each of the 3 treatments. If I now add these 6 values up, I'll get what we call the ChiSquare test statistic. In this case, 10.5. I'll be using this value to help me find the p-value. But before I can do that, I must find the degrees of freedom. Try keeping in mind that the ChiSquare test value is giving me the distances from the observed minus the expected. It always has to be a positive value or at a minimum 0. The only time it can be 0 is when the observed and expected counts are the exact same. The larger your ChiSquare test statistic value, the more evidence you have against the null. So the higher that 10.5 was, or the further it is from 0, would give me more evidence against the null, suggesting the alternative. So there's a formula for degrees of freedom. It's not as simple as it is in the goodness of fit test. The formula is rows minus 1 times columns minus 1. This will enable us to find the p-value, giving me the area to the right under the curve. In our example, we had 3 treatments, giving me 3 rows, 2 outcomes, yeses or nos. 3 minus 1 times 2 minus 1 tells me 2 degrees of freedom. I now go to the table on line 2, start scrolling left to right until I find 10.5. It's not going to be in there exactly, but I want to find the 2 values that bracket it, look up to the top, and get my 2 probabilities. In either case, I know I'm definitely less than 0.05, rejecting the null hypothesis. So I do have significant evidence to suggest the alternative hypothesis, and that is that there is a difference among the 3 proportions, or that there is an association between drug treatment versus relapse, or that drug treatment is not independent of treatment. Drug treatment is not independent of relapse. All 3 of those things say the same thing. We're favoring the alternative hypothesis. So we're always testing there's no relationship between 2 categorical variables. There's several ways you can write that down when you're listing or labeling your null hypothesis. Here's some guidelines on when we should be using the ChiSquare test. So I'll give you a moment to copy those down. You may want to hit pause if you need an extra second. Just like with any significance test, there are rules on when you can and cannot use the significance test. The rules for the ChiSquare test are the same as that of the goodness of fit test. No more than 20% of your expected counts are less than 5, and all individual expected counts are 1 or more. So for an example, for all 4 expected counts in a 2x2, they should be 5 or greater. So that's pretty much it for the ChiSquare test. Now let me show you how you can do all this on the calculator. You're going to need to go back to your 2-way table. We're going to have to enter this matrix into the calculator. Here's how we're going to do that. So I have to enter my yeses and nos as a matrix into the calculator. I'm going to hit second and then matrix. I'm going to scroll to the right and select edit, selecting matrix A. Now I'm defining it as a 3x2, 3 treatment groups, 2 outcomes, yes and no, and entering in the values. Now I'm going to actually run the test. To do that, stat, over to test, and scroll to the ChiSquare test. The calculator prompts me, do you want my observed counts in matrix A? Yes, you do. Notice it says, do you want your expected counts in matrix B? However, I did not type the expected counts in. The calculator knows the formula for expected counts, row total times column total divided by table total. And I don't actually have to type those in. It'll calculate them for me as I run the test. So I just simply go down to calculate. It gives me a ChiSquare test value of 10.5, the exact p-value, and the degrees of freedom from the formula rows minus 1 times column minus 1. Now, for me and anyone grading an AP exam for you, they're going to want to see all of those expected counts and all of the ChiSquare values. Here are the ChiSquare values that I had adding up to the 10.5. And then all of my expected counts. Well, I'm going to grab these expected counts from the calculator. Let me show you how to do that. Back when I was looking at my matrices, second matrix, over to Edit. If I select Matrix B, now that I've run the test, it drops them in for me. So I can just grab these from the calculator to begin with. For you, I need you to just demonstrate that you know how to find one of them. So you'll just do a little demonstration where maybe you circle this 8 on your paper, and you just write down the formula where it came from, and then just get all of the values from the actual calculator. The same thing is going to go for all of these 6 different values that added up to my chi-square test statistic. I need you to demonstrate the formula for just one of them. And then you can very quickly do the other ones on your own. So you give me 14 minus 8 squared divided by 8 equals 4.5, and then just list out the remaining 5. So that's it for the calculator, and that's it for the chi-square test.